Hi. So in this video, we're going to discuss a simple probability thought experiment that I developed to help my students prepare for their final in finite mathematics. So the question is, suppose you have a grid, like any one of these grids here, so that it is dimension 3 by 3, and these little x's represent electrons, or some sort of particle. The question is, what is the probability that no pair of these electrons are adjacent to one another? So we can imagine you have some 3 by 3 grid, and you have a crank or a pull handle, and you pull the switch, and when you do, these pair of electrons pop into existence on this 3 by 3 grid. The question is, what is the probability if the electrons pop into existence randomly and they don't occupy the same space? What is the probability that they are not adjacent to one another? Okay, so what do I mean by adjacent? I mean, like, these two spots are adjacent, these two spots are adjacent, and like those two spots are adjacent. So that's what I mean. So let's go ahead and find this out. So we're going to do this exhaustively. So we're just going to go through the various possibilities. So suppose when you have a pair come into existence, we're gonna think of them as a first and a second pair, or the first element and the second element of the pair. Though the order doesn't actually matter, but it's for counting purposes. So let's say the first one's here, top left, and all of the drawings I'm going to make that are black are going to have the first electron appear at the top left. Okay, so here you have top left, bottom left. I don't want to put it here or here or here, because if I did, then they're adjacent, and the whole point of this scheme is I don't want them to be adjacent to one another. So this seems like a good place to put one. Okay, so that's one. Here's another. So I don't put one here, I put one here. I'm just going to keep going around counterclockwise. So here's another one. Here's another one. Here's another one. So that's 5 pictures where I have one electron in the top left. Can I do any more? Well, no, I can't. If I try putting the second one right here, then they're next to one another, and I can't do that. So let's move the first one down. So if it is at the top left, let's put it in the second position. So right here. Okay. Well, I couldn't put the second one here or here, so this is a good place to start, right? Next, I'm going to move it to here, but I actually skipped that example, but I draw it later, so it's okay. Okay, so here and then here, that's one. Okay, great. Could I put it here? No. Could I put it here? No. So I can either put it here, here, or here, which that's the purple example. It'll turn out to cause no problem. It doesn't matter which one you call the first electron, right? Okay, so now that we've put an element there, the first one there, let's put it in the bottom left. So again, going counterclockwise, bottom right, middle right, top middle, right? And looks like we could put one more here. So let's go ahead and do that. Oh, we can't, right? Because we already did it. So you can't do that. So that's all you have for the green color examples. So let's move on to orange. So if the first one is here, now I'm going to move it over so it's here. Okay, so I could not put the second one here or here. So this is the first place I'm going to put it. Okay, after putting it here, now I'm going to put it there. That's this next example. And would I like to put it here next? I can't, right? Because this example here did it. Okay. So okay, I can't put it there. Can I put it here? No, because then they'd be adjacent, and I can't put it there because they'd be adjacent. So next, I can take this piece and I can put it over here, which is what I did here. That's the brown color. So brown. The second one goes here, and then in this picture I next put it here. Could I put one here and here? Well, yes, and I did it right here, so I don't have to do it again. Okay, so let's. So here and here is not good because I already did it. What about here and here? Well, I already did that right here with the red one, so I can't do that. What about here and here? I did it right here with the green, so I can't do that. So if I did that, the last thing I could do is here and here, but that's not acceptable because the rules said they cannot be adjacent to one another. So next, we move the first electron up one. We're just going in a counterclockwise fashion, both with our second electron and our first. Okay, so if it was at the bottom right, now we just do the right hand side. Now, as I said, I really did not need to do this example. It really is a red example, so I'm going to go ahead and we're going to erase that, and we're going to make it red. And not that the colors actually matter, but the point is though. Okay, so after I did this one, I want to move red up one. It should have been here. I left the picture out. I apologize. So here, and then there. Okay, so that's red. Great. Now, when I move this one up, when I move brown up, okay, I can't do this because I've already done it, right? So what about here and here? Can I do that? No, because I already did it here. What about here and here? Well, no, I can't do that because that's against the rules. So there's no more I can do in this position. In fact, there were none to begin with if you start here, right? So there's none here. What if I put a piece right here at the top right? Well, I have an X through it, so no, you can't. But let's see why. Could I put a second one here? No, because I did that here. Could I put a second piece here? No, because I did that here. What about here and here? No, I did that right there. What about these two? No, I did it here. What about those two? Did it right here. So there's none I can do here. So what about here? Right? Can I do it here? Well, no, I cannot. If it's right here, the first one I could put would be here, so that would be these two positions. But that was done right here. What about top and bottom? Top and bottom? No, that's here. What about here and here? No, that's right here. So that's totally done. And I can't go back here because that's where I started, right? So the only other place to put it would be in the center. But if one of your electrons is in the center, then everything else is adjacent to it. Okay, so let's go ahead and figure out the probability that a pair of electrons are not next to one another. Okay, so here I've drawn all of the ways that you can have a pair of electrons not next to one another. So that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So that's 16 in the numerator. That's the number of ways to have them not next to one another. And divided by the total number of ways you can have 2 electrons, put it in a grid of 9. So that's 9 options, right? 9 locations in your grid. Choose 2. So 9 choose 2. And what is that? Well, that's 9 factorial divided by 9 minus 2 factorial, 7 factorial, right? 2 factorial. Okay, so 9 factorial is 9 times 8 times 7 factorial. So the 7 factorials are going to cancel, and you got 9 times 8 divided by 2. So the 2 divides 8, so you get 9 times 4. And 16 is 4 times 4, right? That's where I get this. These 4s are going to cancel, and you're left over with 4 divided by 9. So I believe in my original solution that I emailed you, I said it was 1/2. I think I may have counted wrong, but anyway, here's the actual solution, and hopefully this is clear. If you have any questions, email me, get back to me, post a comment. Anyway, good luck on your finals. Good luck.